Presentation.
Cool. Hi, everyone. Welcome to this webinar. Today, I'll be presenting about navigating technology and process risk in industrial automation. So let's get started. For introductions, my name is Simon Métivier. I'm a product manager here at Vention. And this will be the agenda for today's session, starting off with an introduction to Vention before jumping into automation. First off, to introduce Vention and our goal, our mission here at Vention is to democratize industrial automation. To do so, we have built a self-serve platform for high-mix manufacturers. By self-serve, we mean that our users, such as manufacturing engineers and plant operators, can design, automate, order, and deploy by themselves in an autonomous fashion. This allows high-mix manufacturers to have more access to automation, as they historically could not easily afford to launch industrial automation projects as a result of their smaller production volume and a high mix of parts. One thing I like to emphasize here in our mission statement that you can see on the slide is with confidence. Since Vention offers cloud-based design and automation tools, this means that user can self-design, self-program, and simulate fully in the cloud before they commit to an investment. A few facts about Vention. We were founded in 2016 and are now 7 years old, nearing 8. We have 3 offices, one in Montreal, one in Berlin, and one in Boston. Our parts ship from 2 distribution centers, one in Montreal and one in Berlin. And we're privileged to serve over 4,000 clients in North America and Europe that span over 25 different industries. Vention has thus far provided more than 16,000 machines in the field and delivers approximately over 200 robot arms per year, both collaborative and industrial. Our rapid growth has only been matched by our ever-expanding client base, today boasting more than 16,000 machines in the field. Of the 4,000 companies we serve, the logos you see on this slide represent some of the most notorious and innovative customers we've had the privilege of working with. That said, we are proud to serve many more, often lesser known businesses such as Mullins Cheese, Revichelf, or Polycar. We feel fortunate to have a wide industry reach, allowing us to develop a tremendous amount of expertise, which in return enhances our capability of developing the right products and the right solution for all industries. With the introduction out of the way, now let's get started with an introduction to automation, but also how to get started. First, a little background on automation in general. High volume manufacturing facilities, like those for cars and consumer electronics, have been automated for decades. However, the vast majority of manufacturing plants in North America, around 80%, are still operated by manual labor. And yet these manufacturers often face the same production cost pressures and labor shortages as their high volume counterparts. Industrial automation is often the best solution, although it can be a daunting one for new manufacturers or first-time automation practitioners. New adopters may find that deployment is costly, production delays are frequent, and it's hard to balance safety requirements with efficiencies. Nevertheless, the need for automation continues to grow, and manufacturers will not be able to avoid adoption for much longer if they wish to remain competitive in their segment. The first question that will often make or break automation project is the associated cost and return on investment. This graph highlights the expected payback for investment into automation. The blue curve that you can see here is basically the type of payback you can achieve based on your production volume. For high mix manufacturers, achieving 1-year ROI can be extremely challenging, especially when considering traditional automation solutions that are more aimed at low mix, high volume manufacturers. So let's take the example, $500,000 project. If you unpack that project, half the cost will be for the technology, usually coming from established manufacturers of industrial automation providers. The other half usually goes to the system integrators or the engineering work that is needed to design, program, and eventually deploy those systems. What Vention does through a self-serve platform is to eliminate the second half. You become the system integrator of your own automation solution. This shrinks the project cost and by default enable manufacturers to automate profitably and autonomously. With the technology provided by Vention, we end up in a world where folks that used to operate the manufacturing floor are becoming the folks that will now design and automate our manufacturing floor. Now you know the financial framework for evaluating automation projects, but how do you set yourself up for success? What process should you follow to ensure you're successful on your automation journey? We've discussed the importance of ROI in the previous section, but there are other compelling reasons to move toward automation. In addition to labor cost savings, maybe you are facing labor shortage issues, or maybe you are looking to solve quality issues, or you have workers exposed to risky jobs, or what we categorize as, dirty dollar dangerous jobs. So the first step to successfully automating is to establish a clear objective. Here are the top 4 reasons that we've seen customers wishing to automate. First one is to realize cost saving. This usually means reducing labor and other recurring operation costs. Value creation will come from comparing existing recurring costs to the current operation, plus adding the project's non-recurring cost, and then comparing that with the reduced recurring cost realized once the automation project has been achieved. Another reason may be to improve product or process quality. So savings here can be realized through defect and scrap reduction, or by reducing dependency on quality inspectors to inspect and validate the output of a manual process. As automation is repeatable, process can now be certified and inspection requirements can be relaxed. Automation also leads toward process optimization, reducing the quantity of consumables required to achieve the desired quality output. Another reason may be to increase production throughput. Usually, increasing throughput implies manufacturing more product by unit of time than with manual labor. Value creation will come from potential labor cost reduction, but also from the marginal profit extracted from the incremental production. For the full value to be captured, one must assume that the market can absorb the extra supply of the manufactured product without the price being eroded. The last reason can be to reduce risk to your personnel. So another reason automate is to reduce exposure to risks. In some instances, could be the main driving force being automating some processes. The industry has come to categorize these processes by using the 3Ds: dirty, dangerous, and dull tasks. As many manufacturing tasks expose workers to repeated physical strain, injuries induced by repetitive tasks or other accidents do occur too often in the manufacturing environment. Automation is a proven approach to reducing the occurrence of these risks. Now, let's discuss what manufacturers can do to take control of their automation journey. There are 3 main steps to this process, and it consists mainly in building what we call at Vention an advanced manufacturing team. The first step is to identify a technical champion. A technical champion is a person that will drive the project forward, the go-to person for internal and external resources to turn to and work directly with management on budgets, approvals, and processes. Preferably, this person should have prior automation experience, but at the very least, this person should be very knowledgeable of the quality requirement and operational constraints, and also roles and responsibilities within their organizations. The technical champion will share their deep technical knowledge within the advanced manufacturing team. They'll establish production guidelines with machine operators, establish maintenance schedules with maintenance personnel, encourage problem-solving tactics amongst all collaborators, and in the case of productized application, or if doing a turnkey project with Vention, they will also be the technical champion and establish the requirements for the automated equipment by owning the completion of the FAT and SAT checklist. So acceptance tests that are both essential documents to ensure a successful automation project in case of turnkey deployment. The second step is to build the advanced manufacturing team. So with your technical champion in place, it's time to build an advanced manufacturing team. Guided by the technical champion, this team is built to select and drive industrial automation initiatives for the company, regrouping expertise in process requirements, mechanical design, industrial control, and robotics. This team develops deep process knowledge to deploy self-designed automated solution in-house rather than relying on external engineering services firms to complete projects. An advanced manufacturing team is a new way for manufacturers to manage their end-to-end automation projects internally, rather than relying on multiple vendors, which typically increases the price of a project and extend the timeline. The last step is to gain support from the top down. The technical champion must effectively pitch the project to the management to secure the necessary funding, resources, and access to the resource. Starting with a well-scoped project, this goes a long way when building expertise, ensuring project success, and increasing the chances of obtaining approval from management on future projects. With a clear goal in mind, you now face a new set of questions. Where should I begin? How? And with whom? Experts generally agree. First-time automation practitioners should begin with a low-risk project and expand from there. Starting with a well-scoped project goes a long way when building your expertise and increasing your chance of success. With that in mind, make sure the ROI or payback is not the only thing you're measuring in. You want to factor building long-lasting expertise as well. That being said, selecting which process to automate consists in a balancing act of feasibility, risk management, and value stream optimization. Be mindful of automating bottleneck processes as much as possible. The last thing we want is to automate processes that result in an increased work in progress volume while maintaining the same total throughput as before. Part of the process of selecting your first project includes evaluating the risks involved with adopting automation and how best to mitigate them and incorporate this information into your strategy. This can be largely broken down into two categories: technology and process risks. Process risk is the ability for the chosen technology to repeatedly operate at desired performance when process input varies significantly from one unit to the next due to manufacturing tolerances and other source of variability. Technology risk, on the other hand, can be interpreted as the level of uncertainty involved in the successful implementation of novel technologies in your manufacturing operations. The TRL scale, or the Technology Readiness Level scale, can inform on the maturity level of selected manufacturing technology, but one should also be mindful of the available skill set within their organization. This is where it can be relevant to discuss upskilling the current workforce. So first, let's discuss process risks. Process risk relates to the operation, task, or process that one is looking to automate. It's owned by the end user of the solution that is being provided. Oftentimes, it can be largely underestimated by teams with the expectation that everything can be automated all at once. Process risk management involves focusing on the process, or SKUs, part numbers, that constitute the majority of the production and descoping edge cases from the first automation project. The 80-20 rule apply here. It's not uncommon that 20% of a production can result in 80% of the cost. Focus rather on automating 80% of the production instead of the 100%, and there's good chances of decreasing the total cost and raising the efficiency of your automation solution that you choose. Technology risk, on the other hand, relates to the technology that is being used to automate a process. It's owned by the one implementing the solution, system integrators, or internal advanced manufacturing teams. And it's easier to de-risk with testing, ensuring component compatibility. Upskilling the organization's workforce can be key here. Ask yourself, do I have the capabilities to operate, troubleshoot, and maintain this type of technology autonomously, or will I require external support? High industry technology readiness does not directly translate to your organization. Set ambitious goal, but aim at raising the ceiling of your internal competencies. So to discuss this in more detail, let's look at a robotic palletizer example to highlight what can be categorized as a process risk versus a technology risk. So the process risk, essentially managing variability induced in manufacturing cycles. So the source of variability in the palletizing process can be the variability of the box orientation as they're presented to the robot. This will require the solution to account for that variability of box orientation. You may have different box sizes as well that could impact the gripper selection. Various weight of the boxes also that could account for what robot or cobot you choose to automate, because the pillar of the robot needs to be accounted for here. And different pallet layout. How many process recipes do we want to support? Technology risk is the question of, is the technology mature and is it within my organization competencies to operate and maintain? So you can ask yourself the question, are cobots technologically mature? In this instance, yes, they are, but it can be argued that 3-axis gantries are even more robust. So what would be the impact on process risks if we choose to go for a 3-axis gantries in relation to a robot? What are the integration requirements? What communication protocol do I use to synchronize all the processes, the conveyors, the robot, and other downstream or upstream processes? Will this equipment need to be integrated with other legacy equipment? So do I understand how I will integrate my robot with other equipment that may be already present in my factory floor? Will I be able to operate, troubleshoot, and maintain this machine? If not, do I need to hire, upskill my workforce, or do I need to delegate some of those operations to external contributors? As an industry, we have made significant progress in extending the technology risk frontier, with breakthroughs such as mission-based programming, digital twin, tactile feedback, and synthetic training. There's a vast array of things that are possible to automate today. Vention aims at empowering manufacturers to take control of their automation journey by helping them push the technology risk frontier. So building the design to deploy workflow as the centerpiece of Vention's self-serve platform, along with the productization of key robotic application and the plug-and-play nature of all our automation hardware all play a significant risk in reducing the technology risk. Also, as manufacturers scale their automation experience and competencies, they will find that they are gradually empowered to take more ambitious projects that have more process risk and technology risk associated to them. And they can do so in a completely autonomous fashion using Vention's self-serve platform. This brings us full circle to Vention and our manufacturing automation platform. As said earlier, the mission of Vention is to democratize industrial automation with a self-serve platform for high-mix manufacturers. Traditionally, industrial automation technologies are project-based, meaning that manufacturers will hire an outside third party to complete the automation project from start to finish. The typical steps for project automations are depicted below. The entire process can last months or even years and involves different experts, each possessing unique process knowledge. And when issues inevitably arise, the manufacturer must call back the expert who holds the process knowledge, hoping this person has not left the company to resolve the issue. In product automation, the automated application or the entire manufacturing floor is created using all the same hardware component and software environment. This approach allows for easy modification and upgrade as the manufacturing floor expands or changes. This Lego-like modular plug-and-play approach ensures flexibility. The other benefit of product automation is the comprehensive support provided. With hardware and software under a single vendor, you can access a customer success team that knows the ins and outs of the product. This team will work alongside you to troubleshoot your issues and provide resolutions, so when a similar problem arises again, you know you have the knowledge to fix it. Speed is crucial here, and having a team of experts a phone call away rather than a drive or a flight away is invaluable to keeping your production's output. So we define ourselves as MAP, the Manufacturing Automation Platform. We're based on 5 pillars, each representing a step in the automation journey. We start with design. Our users arrive on our website and fall into a software that we call Machine Builder, where they can design with industrial Lego bricks. In that environment, we have all the geometric data and metadata of all those Lego parts. Prices, weight, description. Equipped with that data set, we can do a beautiful amount of software automation that would never be possible in a traditional CAD software. We give our users real-time pricing, assembly time, bill of material, and automatic fastener management. We can recommend the next best part for their design, fetching in a library of over 200,000 designs that our team of clients have created before. When we bring one part to the next, we can predict how the user is trying to connect those two parts together. This whole infrastructure that we've built, leveraging the geometric and metadata, just makes the act of design significantly faster and easier. When we're done designing and we have this working prototype, it's time to automate through machine logic. This is the automate pillar. Machine logic is our automation programming software. Within machine logic, users can program their machine either in a visual sequence editor or using a Python API. They can also create their operator HMI and simulate the entire cycle, all from their web browser. They can simulate not only traditional automation, conveyors, pneumatics, actuators, but also robot arms. If they like what they see, they can move on and order the machine from the website. Once they order their equipment, they get it in IKEA-style packaging, flat pack boxes, so they can assemble by themselves using a single Allen wrench. Since Vention controls both the hardware and the software ecosystem, we make sure that from the ideation to the deployment phase, the user experience is seamless. Once it's time to deploy, assembly operations are generated automatically, not unlike IKEA instructions that you may be familiar with, but with the added benefit that the entire machine can be visualized in Machine Builder or CAD tool. Once the setup is complete, the machine motion, which is our own Vention industrial PC, can be synchronized with the user's machine logic session to allow rapid and seamless deployment of new programs. Once the machine has been fully commissioned, the operate pillar assists users with OEE software, what we call machine analytics, as well as remote support in a remote view. Those are products that put users directly in touch with Vention customer success specialists to assist them in troubleshooting problems as soon as they occur on the shop floor. So if you think about all the digital integration and software products we've built with MAP, we've significantly shrunk the time it takes from ideation to deliver an automation solution. We're talking about a couple days or a couple of weeks at max. We're not talking in months. If you look at where the value is created, the cost saving through digital integration will really come from the engineering tasks. So integration, active design, active programming, active deploying, all those manual tasks will take significantly less time. And on average, we see our users deploying 5 times faster using the Vention's platform than going the traditional way, which translates to roughly 40% of the cost of traditional automation. 6 critical sources of value arise when you embrace product-based automation. Some of those values are listed below. So fast ROI, productized application, and self-deployment eliminate non-recurring engineering costs and accelerate return on investment. Intuitive interfaces. Simple user interfaces enable simple training and program updates without any external assistance. Modular and scalable. Platform modularity allows for high customization and easy application upgrades as the factory changes and the manufacturing floor evolves. Field proven. Productized applications built on hardware and software that have been deployed tens of thousands of times. Dependable. Quick access to automation expertise with a dedicated customer service team and on-demand remote support. And future-proof. With 100+ engineers continuously developing the hardware and software platform, applications are supported over the long term, facilitating maintenance and upgrades. So I'd love to end this webinar with a few success stories of customers navigating the risks shared early by going with a product-based automation solution. So first, we have Spectre & Co. Spectre & Co. was looking to remove repetitive and dull tasks from their manufacturing floor so employees could be reallocated to more fulfilling tasks. They also wanted to improve production by introducing more efficient processes. Spectre & Co. knew their automation was the solution to their problems, but with no prior automation experience, they weren't exactly sure where to begin. To fill that knowledge gap, Vention accompanied them along the way to manage both technology and process risk. By adopting an automated solution to a previously 100% manual task, they were able to avoid critical downtimes, increase production, and reallocate workers to more important tasks. By going for a product-based automation solution, they ensured that any modification that may be required in the future could be done very easily on their own. And I'd like to mention here the statement from Linton, the research and development manager over at Spectre & Co. said that Vention really made it simple for us to get in our first robotic project. Their involvement and their guidance helped us implement this new project at our facility, which is a true statement of the value brought by our platform. Another one I'd like to discuss is Rev-A-Shelf. So Rev-A-Shelf was facing similar issues as Spectre & Co., like labor shortages, for instance, but in a different application. So in this instance, we're talking about palletizing. So this was a very large automation project with the implementation of 2 industrial robot palletizer. Rev-A-Shelf was able to reallocate 8 operators to more important tasks. And adopting a solution with the shop floor user in mind, they ensured that there will be little to no ramp up for new and existing employees. This is because we supply them with an intuitive user interface and simple yet effective operation. All this was done in 6 months from pre-sale to deployment for 2 industrial robots, which is very impressive by industry standard. With that being said, I'd like to thank you all for listening, and now we'll open the floor to any questions from the attendees and transition to the live Q&A session. Thank you all.
And thank you, Simon, for that great presentation. It looks like we do have a number of good questions coming in from the audience. And just as a reminder, if you do have any questions as we're proceeding through the ones that are already submitted, you can send in your questions over in that Q&A chat box over on the right-hand side of your screen. So Simon, are you ready to take some questions?
Hi, David. Sure, let's go.
All right. The first question says, could you explain how accurate digital twins contribute to improving process risk in industrial automation?
Sure. Thank you for the question. So how can digital twin contribute to improving process risk or reducing process risk rather, right? Well, when we have a digital twin available either from our web browser or as a standalone software, we're able to simulate the entire workflow of the machine. So the simulation enables us to simulate the nominal condition, right? So you're able to author your recipes, you're able to author your robot programs or other automation routines, but you can also simulate failure modes, right? So if what happens if my palletizer, if my box has a skewed orientation, or what happens if there's an error in the process downstream or upstream, well, you can induce those conditions within your digital twin. You can simulate those. So by being aware of those situations as early as possible, then you can account for the proper failure recovery to be able to have a robust automation solution in place. So that's one of the an example. But another example is, how do you rig your machine, right? So how do you place your robot in the scene? How do you place the different boxes, the pick position, the drop position? So having the ability to do this offline in a digital twin tool means that you're not taking time on the machine. You're not in production. You're not disrupting daily operation. You're doing this completely remote from the operation floor. So that means that you can do all your testing offline, and then once you're ready to deploy, then you reduce the impact on daily manufacturing operations. I hope that answered the question.
And our next question is asking about plug and play hardware. It says, so with plug and play hardware, how do you foresee the integration of such technology helping to reduce technology risk?
Yes, sure. Another great question. So, like I said in the presentation, right, the traditional automation way of doing business is project-based. Means that the integrator gets to the shop floor and they look at all the equipment and they look at all the integration that will need to be done, like selecting third-party equipment, selecting communication protocol, establishing bridges sometimes between legacy equipment and new, more modern IoT equipment. Um, so that means that there's a lot of research and a lot of engineering time that goes into architecturing the automation solution. When you have plug and play solution, and when you make all those decision or all the integration within the same platform, basically you eliminate all those tasks because you know in advance that the hardware and the software will be able to communicate. And when you have the ability of having the software, the hardware platform, the robot authoring tools all within the same platform, it means that you don't spend a lot of time configuring your machine. You spend all the time authoring your programs, right? So this is a lot of value. Most people that are familiar with integrating legacy solution have to spend the time and the research into designing the architecture of the system. This is something you don't have to do when you're dealing with a one single standalone platform that offers all those capabilities natively.
So the next question says, what is skill-based robot programming? And I think if we elaborate on that a little bit, it says that you mentioned that earlier in your talk about it being an emerging technology to address process risk. And can you provide us some examples of how this approach, this skill-based programming approach, differs from traditional robot programming methods?
Yes, it's a very I enjoy talking about this topic of autonomous robotic, skill-based robotic, or mission-based robotic. So basically, the traditional way of programming robot, we're talking about motion-based, right? So there's someone in the organization or the system integrator who detains the process knowledge, and then they have to translate the process knowledge in motion commands to the robot, right? So you need to be aware of speed, you need to be aware of position, you need to be aware of compliance, what kind of process you're automating, what tooling, what the trajectories need to look like. So you need to abstract a lot of that knowledge into and translate it to motion commands. In mission-based robotic, basically you add autonomy to your cell by adding digital twin tools, you add sensors, you add vision, and you begin by teaching those tasks to a robot. So you have a more abstracted layer of robot programming where the robot is aware of its environment and can handle the variability of the manufacturing conditions. So let's say we take the palletizing example, and we know in advance that we're gonna have to deal with the case where the orientation is not so perfectly aligned, or there's other conditions, right? So if we add instrumentation and if we add those instrumentation to our digital twin as well, we can start writing these behaviors, which is for the author, right, or for the end user. You could have a programming task that is just pick the box, right, and behind the task, behind that very seemingly simple command, just pick the box, there's a behavior tree, or there's a structure that lets the robot decide on the best way to pick the box depending on the varying condition of the scene, right? So for instance, if we have a camera that accounts for the position of the position of the box, sorry, then we can program the robot motion in closed loop with the images acquired by the camera. So we start adding those sensors and capabilities so that the robot can autonomously decide what is the best trajectory or what is the best motion command that should be carried out to execute the process. So this requires a lot of knowledge firsthand, to build those programming fundamental blocks. But once you have them in place, you can design this interface where robot programming becomes much more abstract and becomes much more akin to teaching, let's say, a new employee how to do a job, rather than writing, script or motion commands that are very finely grained and that are very, at the atomic level don't mean much. But when you add all those motion commands together, then you have this robot behavior. So it's this new programming paradigm that is opened up by accurate digital twin, by more powerful sensor, and by vision especially also, and by open source platform, such as ROS and the likes.
So it kind of sounds like from that there's an inverse there, as the process gets more and more variable and there's more variations thrown into the process, it becomes a lot more complex. So that's really the goal, is to keep the flexibility while reducing the complexity for both the integrator and the end user.
That's it, right? So there's a lot of thought that is going into this currently. There's a lot of solutions that are starting to emerge. Most of the solutions are not process agnostic, right? So there's companies that will say, okay, we're going to get the sending right? So we're going to have this flat table, and we're going to scan the panels, and we're going to create those surface filling algorithm to create tool paths, right? So it takes a lot of research and development, but from the end user, what you have is you have a robot that responds autonomously to placing a flat panel on a work table, right? And then the next level is to make this completely process agnostic, where the end user would have the building block to program those complex tasks and processes using seemingly very simple command. It's known as a declarative versus imperative programming, right? Imperative programming, you give the recipe, right? You say you add all those ingredients to bake a cake, and then declarative programming or autonomous programming, the motion command becomes bake a cake, right? And then behind it, the tooling and the software kind of figures it out, accounting from sensors that acquire data points from the real world physical cell. So it's much more integrated flow of programming than what we have currently, right?
Well, I see that we are coming close to the end of the questions, but I just want to encourage the audience, if you have any further questions, be sure to send those to us so that we can address them before the end of the session. So the next one here says, I'm intrigued by the concept of synthetic training to improve process risk, or probably to reduce process risk. Can you explain how this approach works and the benefits for automation?
Yes, so this goes very much hand in hand with the previous discussion about autonomous programming. If you start having those sensors in place to acquire those data points in your physical cell, and you have this digital twin where you can kind of simulate the output of those sensors, then you can operate in a closed loop, right? Basically, so you may not know in advance what is the most efficient way, right, or what is the most efficient trajectory for the palletizing example, for instance. You may not know in advance what is the most efficient trajectory for the robot to pick the box and put it on the pallet, right? And as a matter of fact, you don't know the relative position of the robot and the box that will optimize the trajectory to reduce cycle time, right? So this is where synthetic training can help you, right? So the synthetic training, for instance, you could have this this programming environment where you iterate on the relative position on the box and the robot, and you run the system until you converge to the optimized solution, which in this case would be cycle time, right? So the response that you evaluate would be the cycle time, and the parameters would be the position of the robot in the box, right? So this for a human is very hard to do, or it requires a lot of experience to account for some limitation that goes into robot programming. But with this synthetic training, then you can let the solution do all the work for you, right? So you define parameters and you define an output response, and with the output response, you try to find the cost function or the optimization that would translate to where are the box and the robot positioned together in a position that allows me to optimize cycle time and have the best possible trajectories for my application.
All right, well, it looks like we have answered all the questions that have come in so far. However, we still have a couple of more minutes. So Simon, while we wait just a minute to see if there's any more questions that come in, is there anything else that you'd like to elaborate on or make sure that the audience takes away after listening to these Q&As, that some takeaways that you particularly want to leave with the audience today?
Yeah, so I think that the power, talking a bit about Vention and the platform, right? I think that the power of our platform is to enable manufacturers to automate by themselves, right? And the way that we do this is by providing all the software tools available, because we think that the biggest cost that comes from integrating automation is the engineering man hours, right? Like the engineering task, like I said, when you need to integrate different equipment together, when you need to optimize the creation of programs or automation routines, when you need to maintain them or modify them along the way, right? This usually leads to a lot of costs for end users. This is where, to me, the benefit of our platform is the most obvious, because now you have this solution with all those tools in place so that you can upscale your own labor and take control of your automation journey by using the tools that we provide. So we have Machine Builder, which is our CAD tool. So taking pieces of extrusions, you can put together your machine frame. You can import part of your manufacturing plan. So any step file, CAD files that you have, you can import them to your session. So you can design your machine in context and build your digital twin using this CAD tool, right? While you're building this, we update the price. So we know if you add, all the hardware parts that you add, we'll show you the price in real-time update. And for your automation project, when you add a controller and you add a robot, then you open the door to the next pillar of our platform, which is the automate pillar. So this is where we have the tools to help you automate your machine as well. So once you've built it and it's in place, in machine logic, you're able to program those routines, add devices, configure them, and then run simulation in your browser. So all this can be done before you commit to an investment, right? So of course we'll have, by then, you'll probably have a call from us asking if you need a hand or if we can, help you out through your project, and we will want to learn a bit more from you. But you can do this all completely autonomously. And then when you're ready and that you have de-risked your application, then all of this is shipped to your facility in flat pack boxes, and everything is put together using a single Allen wrench. So it's a very disruptive business model. But I think that most people that will relate to this is the people that want to go towards automation. They're high mix, low volume. They have a hard time justifying those projects. And they always have to go to these system integrators because they have their hands full managing quality on the shop floor, managing throughput on the shop floor. So they don't have the time and the peace of mind to evaluate what tools or design these tools, right? And then with this platform, they can go very piecewise, right? And they can do this all into an autonomous fashion. So they don't need to have this whole project done by a system integrator where there's a lot of scoping, there's a lot of engineering hours that go into this. Everything can be done kind of like as a side project. And when you're ready, you purchase the machine, you deploy it, and then you go piecewise. And at the end of the day, maybe 2 or 3 or 5 years, you've completely changed your whole manufacturing floor, and you did it yourself, right? Using the tools and our expertise that we provide. So I think to me, this is the biggest takeaway, and the very concrete way that I think Vention can help organization manage both process and technology risk. And how we do that is we provide the tools so that you can do it yourself. If you don't have the expertise, we can do it for you as well. We can teach you the way. And then after a couple projects with our accompaniment and our documentation and the engineering that we put in our product so that it's all seamless and it's all nicely integrated hardware, software, you're good to go and you can do it yourself after 1 or 2 projects, right? So this is, I think, is the one big takeaway that I would leave you with from this presentation.
Well, I've definitely really appreciated visiting with Vention at various trade shows and seeing your products, and especially your dark blue anodized extrusion pieces at many of the companies that I visited. So you mentioned a disruptive system, but it's definitely being adopted by many of the companies that I've seen and visited. So Simon, thank you very much for an excellent presentation and the great discussion during the Q&As. It was a pleasure working with you today.
Thank you very much, David. Looking forward to do this again.
Now, before we wrap up, I would like to announce the giveaway winners for this session. So 2 winners will receive an event t-shirt and a 6-in-1 multi-use screwdriver, courtesy of Mauser Electronics. Congratulations to Michael Stauffer and Patrick Dunn. We'll be in touch with you after the event to ensure that we have the information that we need to send you your giveaway packages. And folks, please be sure to check out the other live sessions that are happening today. And after this session, we encourage you to visit Vention's booth page where you can browse and access their other content. Thank you for your time, and we look forward to seeing you at another live session again sometime soon.